All right, problem 1-5. On graph paper, graph line mu for m is -1, 1, which I graphed, and u is 4, 5, which I graphed over 4, up 5. And then they want us to calculate the slope of segment or line mu, and then write an equation for the line. Okay, so first things first. When you start doing these problems, there's going to be a lot of different ways to do the problem. So the most important thing is to show your work. So in this particular problem, you start with A, and they want us to show the slope. So I know that slope is y2 minus y1 over x2 minus x1, which, remember guys, is rise over run. Okay, so basically I can take these 2 points, and I've got -1, 1 and 4, 5, and I can plug them into my formula. I always like to stack the points, and so we take the difference of the y's. So if I do the difference of the y's, I'm going to do 5 minus 1. So 5 minus 1. It doesn't matter which direction. You could do 1 minus 5 divided by, since I did 5 minus 1, on the bottom I have to follow that same pattern. So I have to do 4 minus -1. And so this ends up being 5 minus 1 is, what is that, 4? And then 4 minus a negative is plus a positive, which is going to be 5. So my slope is 4/5. Now, a way you can check your work, and probably a way to find the slope even easier, is if we just create our triangle. And the triangle will help us for some other things as well. So as you create this right triangle here, this is the rise, this is the run. So when I look at the rise, it's 1, 2, 3, 4. And when I look at the run, it is 5. All right, so the slope is 4 over 5, so it matches. And so they also wanted us to write an equation. Well, we can write the equation. Let me just get a different color here. We can write the equation by using point slope form. And the equation, we're going to follow y equals mx plus b. And m is the slope and b is the y-intercept. So when we look at this, we're going to get y equals, the slope is 4/5 x plus 2. Now, my graph is off a little bit. I don't know if you could see it. It's off a little here. So that's creating, it's off a little bit here. So it's actually crossing at this point. I know it's not in my graph, but because my graph wasn't right on the graph paper, it's not accurate. But this ends up being my equation. So the next thing they want us to do is they want us to calculate mu, the distance. They want this distance right here. Well, what we need to remember, I'm going to get a different color pen now. This is B, is when we're looking for distance of a right triangle, we're going to use the Pythagorean Theorem. So a squared plus b squared equals c squared. And so we get 5 squared plus 4 squared equals c squared. And so we get 25 plus 16 equals c squared. So this ends up being 6 and 5, that's 11, 1 is 41 equals c squared. But we don't want c squared, we want c, so we take the square root of c squared, which is c, and then we take the square root of 41, which, as an exact answer, this is our correct answer, the square root of 41. If we want to make it a decimal, and typically we do that to 2 decimal places, the square root of 41 is 6.40. Okay, so when they say 2 decimal places or to the nearest hundredth, this would be 6.40. And so that's our answer. All right, now in C it says, are there any similarities to the calculations used in parts A and B? All right, so let me get a different color again. Let's try green. All right, so for this, they want similarities and differences. So the first thing I'm going to say is similarities. What's the same? Well, the big thing that I see is that 4 and 5 are used in the slope calculations, and they're also used in the distance of MU calculations. So I'm going to say both 4 and 5 are used. Okay. What else? They're both using a right triangle. Using a right triangle. I'm going to abbreviate, that's triangle. All right. And I think that's pretty much all I can see that's the same. Okay, so then the next thing we want to do is we want to look at differences. And by the way, my answers aren't always have every single answer there. You might have come up with some other things here. And if you want to come talk to me about it, that'd be great. So differences. Well, I think one of the differences is we use different formulas to come up with the slope and the distance. So use different formulas. Another difference is you're finding different types of measurements. Let's say our length and steepness. So those are two different things. Formulas are different. What else? One thing I see is the length isn't in the equation of a line. Length is not a part of equation of line. Okay, so I think we've come up with a pretty good list there. Like I said, you might have some different things here. The idea is that you're thinking and evaluating.